Hi everyone in Algebra 2B. Today we're going to be going over the new material in lesson 104. We're going to be writing decimal numbers as fractions and even repeating decimal numbers as fractions. I'm going to show you how that's going to work. So to start off, we say that a number that can be written as a fraction of integers is a rational number. So that's what we're trying to do. So we're trying to write these decimal numbers as rational numbers, so written as fractions. And in order to do that, I'm going to just show you some examples. We're going to do 104.1 and 104.2. And then I'm going to also show you how to do this with repeating decimals as well. So starting with 104.1, it says show that 0.001 or 314 is a rational number, and we're going to write this as a fraction. So the first thing that I'm going to do is I need to recognize what I would need to multiply this by to get this to become a whole number. So if I would need to move the decimal point over 1, 2, 3, 4, 5. So I would say 0.00314 times, and I would have to multiply top and bottom by this. So that would be 10 to the 5th over 10 to the 5th. Now if I did that, when I multiply the top by 10 to the 5th, I would get 314. And then I would divide that by, well, I have to multiply 10 to the 5th, which would actually be 10. 1, 2, missing 1 0. And it would be 314 over 100,000. You could reduce this fraction to its lowest term, but this reduction is not required because any fraction of integers satisfies the requirement. So it doesn't have to be simplified all the way in order for us to get the correct answer. So this would be our result. So basically what I did is I turned my decimal number into a whole number by multiplying it by 10 to the however many spaces it needs to be, and then putting it over that number. So notice that on the bottom, though, there is 1, 2, 3, 4, 5. There's 5 zeros, 10 to the 5th. Okay, so for the next one, I would need to move this up, multiply this by 1, 2, 3, 4, 5, 6, 7, 8. So that would be 0.023. And I said that has to be to the 8th. So that would be 10 to the 8th over 10 to the 8th. And when I do that, I would get 623 in the numerator. And in the denominator, I have 1, 2, 3, 4, 5, 6, 7, 8 zeros. So that would be over 100 million, and this would be my answer. So I wrote it as a fraction. So that's all you need to do for these problems. The repeating decimal numbers are going to be different though. So we can eliminate these repeating digits by subtracting one number from the product of your number and 100. So you're going to be multiplying your given number by 100 and then subtracting your original number from it, and then just solving for what n is equal to, and that will give you some kind of number, a fraction, and then you can turn that into a whole number by just moving the decimal point over, just like we did on the last one. So if I was given this number 0.01623, that would be my A. So that's going to be my number, and that means that we're repeating 23. Then I'm going to multiply it by 100. So when I multiply that by 100, it moves the decimal place over 2 spaces, and this becomes my number with the repeating decimal 232323. Then what I'm going to do is I'm going to subtract the n from the 100n. So 100n minus the n gives me 99n on the left side. And on the right side, so if I do 1.623 minus 0.01623, we would get 0.1 or 1.607. as our result. And so then to solve for n, I would divide both sides by 99. And then all I would need to do is move the decimal point over 3 spaces on top and bottom, and that would be my result. Okay, so multiplying your number by 100 and then subtracting the two numbers and then finding the difference between the two. Okay, so for number 104.4, it says show that 1.00311543 is a rational number by writing it as a quotient of integers. So I'm going to say that my n is going to be equal to 1.003153, and that's a repeating decimal. And so for this 543, this is where I want my number to match up with. So I need to multiply this by 1,000 so that this shifts over so that the 543s match up. So I'm going to multiply this by 1,000. So it'll be 1,000 n, and if I move this over 1, 2, 3 spaces, that would be 1,003.1543, then 5, 4, 3, 5, 4, 3, and the repeating decimal, and we're trying to subtract these. So what we're trying to do is we're trying to match it so that the 543s line up. And when I subtract this, the 543s are going to cancel. The repeating decimal is going to cancel. Now you can use your calculator. So it would be 1,003.1543 minus 1.0031. And that's going to give us, 1,000 n would give us 999. N is equal to 1,002.1512. So if I divide both sides by 999, but then I want this to be a whole number divided by a whole number. So I would need to move the decimal point over. So I would need to move it over 1, 2, 3, 4 spaces. So 1, 2, 3, 4 on top and bottom. And that would give me my n is going to be equal to 1,002.1512 divided by 999.123.4. And this would be your answer. So it all depends on kind of that repeating number on what you're going to multiply the number by. So then we're going to move on to number 104.5. It says to show that 13.012 repeating decimal is 2 is a rational number. So I'm going to say n is going to be equal to 13.01222. And this is a repeating decimal. I'm going to multiply this by 10. So this would be 10 n is equal to, so if I multiply it by 10, it would be 130.1222. This would be the repeating decimal. And then I would basically get 130.12. 100. So all of these repeating decimals are going to cancel. So I have 130.12 minus 13.01. And that would give me, when I subtract that, I would get 9n is equal to 117.11. Divide both sides by 9, but again, you want to have a whole number. So I'm going to multiply it by 100, and that would give me n is equal to 11,711 divided by 900, and that would be your result. So these ones are a little bit trickier, But now we're going to move on to lesson 104, numbers 5, 6, 7, and 10. So I want you to pause the video and attempt these problems before pressing play so that we can do them together. So numbers 5, 6, 7, and 10. Okay, so starting with number 5, the problem is from lesson 101. It says, at the bazaar, Deeb paid the Burke $2,400 for the rug. If the Burke had only paid $400 for the rug, what was the markup as a percentage of cost, and what was the markup as a percentage of the selling price? So it says that the markup is a percentage of this. What was the markup as a percentage of cost, and what was the markup as a percentage of the selling price? So we have, for number 5, from that lesson, we have this equation here. We have the selling price is equal to the purchase price plus the markup. So for number 5, we have selling price equals purchase price plus markup. And for this one, it says that they're selling it for $2,400 and they had paid $400 for it. So we're gonna be solving for the markup. So this would be $2,400 equals 400 plus markup. So if I subtract by 400, I basically get 2,000 is equal to the markup. Now the markup's either the percentage of the selling price or the percentage of the purchase price. So what we're gonna do is we're gonna solve for what the percentage of the purchase price was or the percentage of the selling price was. So I'm going to change this to 2,000 is equal to percent of the purchase price. We know what the purchase price was. We know that that was 400. So when I divide both sides by 400, I get 5 equals the percent. But remember, whenever you're dealing with percent, we would have to multiply that by 100. So this is for this is basically over 100. So I need to multiply both sides by 100. So I get, it would be 500% of the purchase price. And then for the other one, I would do 2,000 equals the markup. And this time it's going to be the percent of the selling price. And so again, percent's always over 100. And my selling price is 2,400. So if I divide 2,000 divided by 2,400, I get this decimal number of 0.833. And then I would need to multiply that by 100. So it'd be 0.8333 equals to the percent over 100. And then when I multiply that by 100, I get, it would be 83.33% of the selling price. And that would be your result for number 5. So number 5 is a little trickier than the ones that we have been doing. So it is something that you probably needed to just watch the video for. Now, moving on, we're going to be looking at number 6. So for number 6, what we're going to do is I need to figure out what I need to multiply this by so that it becomes a whole number. So 1, 2, 3, 4, 5, 6, 7, 8. So that would be 0.000000512 times 10 to the 8th over 10 to the 8th, which would make that 512. And 10 to the 8th, written as a whole number, would just be 1 with 8 zeros. So 1, 2, 3, 4, 5, 6, 7, 8. And this would be my result. So 512 over 100 million. Now for the next one, this is that tricky one. So my n is going to be equal to this number right here. So my n is going to be equal to 0.01432 2. So basically what I would need to do is, in order for this 32 to match up, I would need to move this decimal over 2 spaces, meaning that I'm going to multiply it by 100, and that would give me 1.4323232. And I'm subtracting these so that the 32's cancel. The repeating decimal does cancel, so all the repeating decimal cancels. On the left-hand side, I would subtract n from 100, so that would be 99n. And on the right-hand side, I would do 1.432 minus 0.014, which would give me 1.418. And then I'm going to divide both sides by 99. And then again, so that it's not a decimal point, I would move the decimal point over 1, 2, 3 spaces on top and bottom, meaning that my number is going to be equal to 1,418 over 99 with 1, 2, 3 zeros. And that would be your result for number 7. Now moving on to number 10, we are going to divide. So number 10 was from the last lesson, lesson 103. So we're just dividing. And then we're going to start with m minus p on the outside, and on the inside, I have to start with my highest power, m to the 3rd, plus 0, m squared, plus 0, m, and then minus p cubed. So I'm going to divide my m cubed by m, which would just be m squared. Now multiply, so m squared times m would be m cubed. M squared times negative p squared would be negative pm squared. But because we're subtracting, we're going to change the signs from positive to negative and negative to positive. My m cubes cancel. When I add 0 to this, it would just be what the pm squared. We're going to carry down the 0m. When I divide this by m again, I get plus pm. I need to multiply, so pm times m would be pm squared. Pm times negative p would be negative p squared m. But again, you're subtracting, so the signs change from positive to negative and negative to positive. The pm squareds cancel. I'm left with p squared m. Now, if I divide this by m, I would get just p squared. P squared times m would be p squared m. P squared times negative p would be negative p cubed. But again, you're subtracting, so this changes to negative, this changes to positive. Not only does the p squared m cancel, but also the p cubed, which means that your answer is just going to be m squared plus pm plus p squared. So it's long division just with multiple variables, and that's from lesson 103. Okay, and that concludes the problems that we're going to do for lesson 104. Please make sure that you list all of your questions for 104A by Friday morning at 9 a.m. And there's also a test tomorrow, so I hope you guys all have a great day. Bye.